Okay, welcome back. We're going to do section 2.6 in Martin Gay's Intermediate Algebra. It's about the absolute value. And we're going to do the even numbers, 2 to 38. Number 2 is the absolute value of y is equal to 15. Now the absolute value of a function has to do with the magnitude of a number. So if a number is positive, the absolute value is just equal to the number. If a number is negative, then the absolute value is the negative of the number. So if we take the number line, the idea is that if you take the number -2, its absolute value is 2. If you take the number +2, its absolute value is 2. The absolute value is the distance of the number from 0, from the midpoint. It's sometimes called the magnitude of the number. It's how large it is, but not if you ignore the sign of it, whether it was positive or negative. Okay? It's like if you had someone that was famous, but they could be good or they could be bad. If they're very, very bad, or they could be very, very good. You have Hitler or you have Jesus Christ. In magnitude, it's similar, but one is the opposite of the other. Okay, now, here we have the absolute value of y is equal to 15. Well, this tells us basically, this is just a starter problem. This is easy. The solution is that y is equal to -15 or +15. It's one or the other. I also like to write this as simply saying it's plus or minus 15. Okay? There are two solutions to this problem. Okay, now let's go to the next one. Next one is quite similar. 6n is equal to 12.6. Okay. Well, there are a couple of things that we can do. We could divide both sides by the 6. Or we could also say that 6n is equal to plus or minus 12.6. The n is equal to plus or minus 12.6 divided by 6, which is equal to plus or minus 2.1, which could also be written as the set -2.1, +2.1. There's also two solutions here. Okay. Okay, number 6 says 6 plus 2n equals 4. Now, this is really two equations. One of them is if 6 plus 2n were equal to 4, that would be a solution to this equation. If 6 plus 2n was equal to -4, that would also represent a solution. So I think one way to conveniently solve this is by simply saying 6 plus 2n is equal to plus or minus 4, for example, and then solve that. And you could solve that as saying 6n is equal to plus or minus 4 minus 6, or n is equal to plus or minus 4 over 2 minus 3. I just moved the 2 over to the other side. This is plus or minus 2 minus 3, n equals. And there are two answers here. One of them is going to be -1. That's when I take plus 2 minus 3, and the other is -5. And on something like this, it's very helpful to take your number and to plug it back in to see if it's really a solution. like if n were equal to -1, that would say 6 minus 2 is equal to 4, which is correct. And if n is equal to -5, you'd have 6 minus 10. That's equal to -4, but the absolute value of that is 4. So that's just a way of checking your answer. Okay? Okay, the next one. N over 3 plus 2 equals 4. And the way that we just solved the last one should also work here, okay? N over 3 plus 2, I'm sorry, equal to plus or minus 4. This will allow us to solve this more readily. Move over the 2, multiply, take the 3 out of the bottom here and multiply it by it on this side, and we'll have n is equal to the plus or minus 2 minus, plus or minus 4 minus the 2, and then multiplied by the 3. This is going to have two answers. One of them is the 4 minus the 2. That's 2 times 3, or 6. And the second answer is -4, -2. That's -6 times 3. That's -18. Those are the two possible answers. And you could plug those in, and you should get the same thing as we did. Okay, I won't plug those in, but you can do that. Okay, here's another one. Magnitude of x plus 1 equals 3. Okay. Well, we could certainly bring the 1 over to the other side and make it magnitude of x is equal to 3 minus 1, which is equal to 2. And from there, you can see it's the same as the previous problem. X is equal to plus or minus 2, which is equal to -2 or 2. Two solutions to that problem. Okay. Absolute value of 2x minus 6 equals 4. Or the absolute value of 2x is equal to 10, bringing that 6 over to the other side as a positive 6. And we can divide both sides by the 2 here. If there's a 2 in the absolute value, that's fine. We can divide both sides by 2, and that will cancel out. So this would be the same as 10 divided by 2, and that's going to just be equal to x equals plus or minus 5. Okay. Now, number 14 says the absolute value of 7z equals 0. Now, the only way for the magnitude of the absolute value of any number to be equal to 0 is for that number to be equal to 0. So we can immediately say that the only solution to this is that z is equal to 0. Okay? Now let's try this one. 3z minus 2 plus 1, plus 8 equals 1. Okay? Now we can move the 8 over to the other side, and we'll get 3z minus 2 is equal to -7. Now this is a trick question. I have to admit, when I first did this one, I got it wrong. I wasn't thinking about this enough, and I just started doing these problems. I actually did this one on the board on a previous video, and then I got it totally wrong. I deleted that video. the thing is, if you take the absolute value of a number, you will never get a negative. So there's no solution to this. No matter what value you put in for z, whether this on the left side were to be a positive number inside the absolute value or a negative number inside the absolute value, you can never take the absolute value and end up with -7. So really, z here, the answer is that the z is equal to the so-called empty set, which is there's no solution. Okay? That's the set of solutions, is null. Okay, now 3y plus 2 equal to 0. The only way for this to be the case is if what's inside the absolute value is equal to 0. And then we can say that y is equal to -2/3. Notice I did that entirely in my head. I put -2 divided by 3, and without doing any additional steps, I just wrote it down, okay? And I want you to practice that type of thing on the simple cases, solving the algebra. Okay, now, this gets us to number 20. This, I will say, is another one that I got wrong the first time I did this section. 9y plus 1 absolute value equals the absolute value of 6y plus 4. Okay, this now is just starting to get tricky because they're putting a lot of stuff in there. Now, you could probably do this a lot of different ways. And finally, the real answer is that when you finally get your so-called answer, if you plug it back in, you can tell whether or not your solutions are correct solutions or whether they're bogus. But on this one, I did check the way they recommended to do it in the book, and I liked the way that they recommended. And that was, if this turns out to be a positive number, and if this turns out to be a positive number, then the absolute values are not doing anything. And the equation can be solved by just setting 9y plus 1 equal to 6y plus 4. If what's inside here is a negative number, and what's over here is a negative number, and they're equal to each other, then the absolute value is just going to take away both of those negatives, and you'll get a solution. So one solution to this is that if 9y plus 1 is equal to 6y plus 4, any solution to this equation will satisfy this, because whether or not this be positive on both sides or negative on both sides, it'll be a solution. Okay, so let's just solve that one. That comes out pretty easy. That's 3y is equal to 3, or y equals 1. And if you put y equals 1 in there, you'll see that this is 10 equals 10. So that's definitely a solution. Now, a second solution to this is if what's in here is the opposite in sign to what's in there. Or in other words, if 9y plus 1 is equal to the negative of 6y plus 4, then any solution to this is going to satisfy this equation, because if this were to be a positive number, then what's inside here would have to be a negative number, but equal in magnitude. Okay. Yeah, so we can solve this one. We bring the 6y over, we get 15y plus 1 is equal to -4. Bring that 1 over, we get 15y is equal to -3, or y is equal to -1/5. I brought the 15 over, I canceled the common factor 3 in the 2, and I got -1/5. And that's not quite so obvious that that would be a correct answer there. You'd have to plug those in, see if that's correct, but that's not too terrible. In other words, 9 over 5 negative plus 1 absolute value equals 6 over 5 negative plus 4. Is this correct? Well, this 1 is equal to 5 over 5, so on this side it reads negative 4/5 absolute value. Getting sloppy today. Okay. Now, plus 4. 4 is equal to 20/5. 6/5 plus 4. Did I get that right, or did I? Let's see. That's 15y negative 4. I'm sorry, this is a mistake. So when I bring this 1 over here, that would be negative 4 minus 1. That should have been a negative 5. Okay, so I found an error because by checking it back in, I did find that I had an error. This should be y is equal to negative 1/3. My apologies. Okay, and then to verify if this is the correct answer, I plug it in, and I get negative 9/3 plus 1 is equal to negative 6/3 plus 4. This is negative 3 plus 1 is negative 2. On this side, this is equal to negative 2 plus 4, or positive 2. So you can see this is also a solution. So this has two solutions, 1 and negative 3. So I think you will get this same. I think you can also solve this in this way. If you take 9y plus 1 is equal to 6y plus 4. And then if you say if the plus or minus of this is equal to the plus or minus of that, which is to say if plus 9y plus 1 is equal to plus 9y plus 4, or if minus that is equal to minus that, or any combination of those. The plus or minus of this equals the plus or minus. That would actually give you 4 equations, but that will reduce to just 2 equations. One where this expression is equal to this expression, and the other is where it's equal to the opposite of that. So I'm going to say this is definitely a tricky problem, and it takes practice, having done one of them before you develop a good technique. But remember, always when you check your answer by putting your solution in, and that always is a way to tell you if your solutions are correct. It doesn't tell you if you have captured all of the solutions. If there's more than one, you might get one solution which is correct. Okay, so having had some practice on the previous one, we're going to say that one possible solution to this will be 2x minus 5 is equal to 2x plus 5. Okay, and for this one, these are going to cancel because they're the same on both sides, and you're going to end up with 0 is equal to 10. So this is going to be the so-called null set. In other words, there is no value of x which will cause this expression to equal that expression. So we move on to the next possibility, which is 2x minus 5 is equal to the negative of 2x plus 5. Okay, now we move that over to become a 4x minus 5 is equal to negative 5, or 4x is equal to 0, because now these cancel. When you ever have two on the same side of the equation that are identical, they just cancel. And this leads to x equals 0. That turns out to be the only solution to this one. Okay? Also, quite interesting and a little bit tricky because of the way that one of these led to no solution possible for x. That gives you the empty set. So x equals 0 is the only solution. Okay, now let's move on. For some reason now, number 24 says absolute value of x equals 1, but this looks just like back to the type of problem we started with. this is just x is equal to -1 or 1. It's equal to plus or minus 1. Okay, two solutions, but quite easy. That's what we started with. And then number 26 says y is equal to 8. Well, same story. This is just equal to -8 or +8. There are two solutions. That's just like what we started with. Okay, now absolute value of y is equal to -9. Okay, now this is the trick. This one is quite clearly the trick problem because it's saying that you want a number whose absolute value is a negative number, but there is no such number. So this is just the empty set. Okay? I don't know if you can simply, probably it's not necessary to put the empty set into a bracket. It's probably, I guess, I just looked in the book there. What they want is the empty set is just that number, 0 with the line through it. Y is equal to the empty set. Or you could say y is equal, or another way of writing the empty set by putting the brackets with nothing inside it. I guess they don't put the brackets and then put the empty set symbol inside it. Okay, but that's really just a question of notation. Okay, notation. There's no solution to that problem. Okay, that's what I call a trick problem. Okay, the next one is 4m plus 5 equal to 5. Okay. Now, there are two possible solutions. Either 4m plus 5 is going to be equal to +5, or 4m plus 5 is going to be equal to -5. Either of those would represent a solution, so I'll solve it like this. Oh, actually, let me solve it like this. And let me do this technique. I'll do 4m plus 5 is equal to plus or minus 5, okay? And then I'll use regular rules of algebra. I'll take away the 4. Those are the two possible answers. One of them is going to be, I'll take the positive sign to get one of the answers. That's going to be +5, -5, or 0. So one answer is going to be 0. The next one, I'll take the negative. That'll give -5, -5, that's -10, over 4, that's -2.5. So there are two solutions, okay? 0 and -2.5. That's number 30. Okay, now let's move on to 32. 7z plus 1 equals 22. The key to doing these problems is practice. You make mistakes just like you would practice anything. The more you practice, you get better at it. And it's not that you become smarter, it's just that you have more practice with those particular problems. And when you have problems like those, you're going to get them quicker. Okay, so on this one, we're just going to take the 1 and subtract it from the other side. 7z is equal to 21, which means that 7z, that is the absolute value of 7z is equal to 21, or 7z is equal to plus or minus 21. Z is equal to plus or minus 21 divided by 7, which is equal to plus or minus 3. And those are the two answers. Z is equal to -3 or +3. Two possible answers. Okay? Okay, 5m is equal to -10. Now, this immediately now sets off a red flag. It would be easy to proceed with this, potentially setting 5m equal to plus or minus 10, but that's a mistake. See, I made that mistake earlier when I first started this assignment. This is a trick, because the absolute value of 5m can never equal a negative number. There is no solution. So m is equal to the empty set. There is no solution, or also known as the empty set. No solution. Okay, x plus 4, absolute value, minus 4 equals 1. Or x plus 4, max absolute value, is equal to 5. Okay? Or x plus 4 is equal to plus or minus 5. Or x is equal to plus or minus 5 minus 4, which there'll be two answers. One is the plus 1, and the other one is negative 9. Okay? Okay. C, 5 minus 1 equal to negative 2. Well, this is going to be another one of those tricks. They keep throwing them in. There's no way this could ever possibly have an answer, because when you take the absolute value of whatever the expression is in here, whatever the value of C happens to be, you can never end up with a negative. So, empty set. There are no solutions to this. Okay, that brings us up to 38, and that's all for today. Okay, thank you, and I'll see you next time.